objective for today, oh my bad. The home plate for tonight is page 198 only. 198 only. And reminder, there is tutoring. It's free. All right. So our objective for today, I can solve systems of equations. I can solve systems of equations. At the beginning of the school year, the first 3 weeks, we did a full review for Algebra 1. I can solve systems of linear equations. But now we're no longer just on linear. We are in what? Linear and quadratic. So, but it's still system. Okay? So quick recap. Let's see if we remember. Oh, by the way. Anyways, so systems of equations. What different methods did we use to solve it? We had 3 different methods. The first one was graphing. The second one was substitution. And the third one was elimination. We've been practicing all of them. The ones that we've been using the most is graphing. Remember those? With inequalities, we highlighted stuff, but we kept graphing systems. Substitution, we've been solving with substitution in the warm-ups. And now I'm bringing back elimination because that's probably the easiest method. Okay? Also, quadratic equations. Now think about it. Not system, just an equation. What method have we been using to solve? We've been solving by completing the square. Have we been practicing that? Yes. Did we cover quadratic formula? Yes. How about by square roots? Yes. How about by graphing? Yes. The one that we've neglected a little bit, but we have been practicing, is factoring by grouping. Kind of like the one that was on the warm-up, but we haven't done that in a couple weeks, but we did cover that. So those are the different methods that you're going to have to choose in regards to which one to use to solve whatever quadratic equation you end up at the end. Okay? So with that said, write this down in your prayer model. Systems of equations. What are systems of equations? Systems of equations is the set of 2 or more equations that have the same variables. The set of 2 or more equations that have the same variables. Examples: y equals x squared plus 5x plus 6, and x minus y equals -3. And the other set is y plus 3x equals 0, and y minus 6 equals -3x squared. Copy that. All right, according to the definition, I think it's pretty obvious. It says the set of 2 or more equations that have the same variable. Here's the set. Do we have 2 or more equations? Yes. Do they have the same variables? Yes. How about here? Yes. 2 or more equations? Yes. Same variables? Yes. All right. None examples. Tell your neighbor why that's not a system of equations. Be nice. Be nice. Yeah, Chance said they don't have the same variables. That is correct. X and Y, A and B. All right? So think about what makes a system of equations. Write a couple of hashtags. Share one with your neighbor, please. Hashtag. All right, let's see. Lene. Hashtag what? Same variables. Thank you. Another one. Kenzie. What? 2 or more EQs. Yes. Hashtag equations. Yeah, they have to be equations. Hashtag. Bam. All right. So, turn your paper over in the back. Copy this one, please. Huh? Okay. What? We're just sharing information. Uh, oh, that's a good one, Leo. Eso yo no. I tell you, look at that. I see something from the ponies. I'm like, my legs are freezing. Okay. Oh, it's because the fan is pointing to you. Point it to me. All right. It says, solve the system by substitution, elimination, and graphing. All right. So, which method shall we start with? Ethan? Elimination. All right. So, circle elimination. We're going to do that method first. In order for us to start with elimination, both equations need to be in the same form. Tell you never what I just said, please. So right now they look all scrambled up, so I'm going to solve each one for y and set it to y. So this one, in order to leave y by itself, what do? Add 6x, add 6x. So my new equation is y equals x squared plus 6x plus 5. Look at the second one. Is this already in y form? No, I add x to each side. So my new equation is y equals x plus 1. Now, do they have the same form? Yes, they're both in y form. However, it's called elimination because the very first step, we need to eliminate one of the variables. Would it be possible for me to eliminate the x? Look at it. Can I eliminate the x? And no, because there's a bunch of x's all over the place. Which is the only one that's pretty much close to being eliminated? The y. Now check this out. In order for me to eliminate the y, this second one has to be a what? A negative. That means I'm going to multiply the entire equation times negative 1. So that gives me negative y equals negative x and negative 1. And so that I don't get confused, now that I transform this one, this is my new equation, I'm no longer going to use this one. I'm focusing on the first and this one. So with that said, can we eliminate one of the variables? Yes. What is y minus y? 0. Yeah, so this one and this one eliminated. That's why this method is called elimination. We're left with x squared. What is 6x minus x? 5x. And what is 5 minus 1? 4. All right. You're like, Mr. Q, okay, that looks very familiar. Okay, so now we're left with a quadratic equation. What method, which of the 5 methods would you like to use to solve that one? Let's go, Chance. That's 2 for 2. He said Power Rangers. Yeah, let's do by factoring, by grouping. Here we go. Which one goes on top? 4. That's our product. The middle term goes down here. That's our sum. What factors of 4 add up to 5? 1 and 4. That is correct. So let's rewrite this. Focus. First term is x squared. The second term, instead of 5x, what do I write? 1x and 4x. So plus 1x plus 4x. Then I bring down the last term, which is plus 4, and all that equal to 0. All right. So this is factoring by grouping. So that means we need to group the first 2 and the second 2. All right. So what is GCF here for the first 2? X, and I'm left with x plus 1. GCF for the second 2, 4, and I'm left with x plus 1, and all that equal to 0. Let me scoot up so people can see from the back. There it is. All right. So What's the same here and here? X plus 1, that's my first factor. X plus 1. And what's left? X plus 4. And all that equal to 0. And now I'm left 2 steps. 1, to write each of those equal to 0 and to solve for x. So x plus 1 equal to 0. X plus 4 equal to 0. This is a zero product property. So then minus 1 minus 1, x equals negative 1. Minus 4 minus 4, x equals negative 4. Am I done, Mr. Q? No. We just solved the equation of both lines or both equations combined. But is that the solution to the system? No, the solution to the system is what? A point. Or in this case, how many x's do we have? 2. So it's going to be how many points? 2. Now we need to find y. The variable y. We need to solve for y. So I'm going to take the second equation. What was my second equation here? So I'm going to write it twice. Negative y equals negative x minus 1. Negative y equals negative x minus 1. Why do we write it twice, Mr. Q? Because we have 2 x values that we need to substitute in there. The first one is what? Negative 1. And the second one is negative 4. Let me zoom in. Bring everything else down. Negative y equals negative times negative 1 minus 1. Negative y equals, what is negative times a negative? Positive 1 minus 1. Negative y equals 0. That means y equals to 0. So what does that mean, Mr. Q? That when x is what? Negative 1, what is y? 0. All right, let me do the same to this one. Negative y equals negative times negative 1 minus 1. Negative y equals 4 minus 1. Negative y equals 3. I need to divide by negative 1, so that leaves me with y equals 3. Oh, negative 3, sorry. Negative 3. So what does that mean, Mr. Q? That when x is negative 4, y is negative 3. And what are these? My solutions. Now, this is a system. What does that mean? What do those 2 points mean? Talk it over to your neighbor. What does it mean that they're solutions? What does it mean? Solutions. Daniel, say it out loud, please, for everybody to remember. That's where both graphs intersect. That's where both graphs intersect. So with any system, doesn't matter what kind of functions you have, where they intersect, that's a solution. So, let me zoom out. Now look at that. Now, some of you are like, Mr. Gill, how come we're getting 2? Well, let's look at the type of equation that we have. What is this one? A parabola. What is this one? A line. So that means this line intercepts that at 2 points. Yeah, that's pretty possible. All right, so we're done with what? Elimination. What's next? Substitution. All right. Josh, write that down again. But now we're going to go with substitution. Nice. All right. All right. So for substitution, what do we know? That one of the equations has to be solved for one variable in order to substitute it into the other equation. Which one's easier to solve? The second one or the first one? Second. So that means I'm going to do what? Plus x plus x. So my equation is y equals x plus 1. What does that mean, Mr. Q? Well, that y is now what? X plus 1. What does that tell us from the first equation? Now, instead of writing y, what do we write? x plus 1, and then the rest of the stuff. Yes. So I'm going to rewrite this equation. Instead of y, we said we write x plus 1. What's next? Minus 6x equals x squared plus 5. All right. What do you notice? Just x values, yes? And what kind of equation is it? A quadratic, yes? So, think about it. What is the first step in solving quadratic equations? The very first step. Think about it. First step, the most important step in solving quadratic equations. Tell your neighbor. Go. Close. Let's see. Jake, the most important step. A quadratic equation has to be. Okay, yes, but it has to be what? Yes. Standard form, but it has to be equal to 0. It has to be equal to 0. Remember the y, we turn it into 0. One side has to be 0. So, yes, I'm serious. So, I need to get rid of all of this to make it equal to 0. So what do? Minus x minus 1 plus 6x. Minus x minus 1 plus 6x. Some of you are like, Mr. Q, couldn't we combine stuff here first? Yeah, but I just wanted to do this step first to make it equal to 0. Bring down the x squared. Now we can combine. What is negative x plus 6x? 5x. All right. And what is 5 minus 1? 4. All right. So we end up with a quadratic equation. What method do we use to solve? We can't. It's not a perfect square. It is a perfect square? Okay, somebody said it is. Let's prove that it's not. Let's see. Hold on. Let's see. Square root x square root 2 sign of the middle plus. So you're saying this is this. Let's see if it's true. What's another way of writing this? X plus 2 times x plus 2. What is x times x? X squared. What is x times 2? 2x. What is 2 times x? 2x. What is 2 times 2? 4. What is this? X squared plus 4x plus 4. Is that this? Oh my goodness. Yeah, not bad. So yeah, the only time when it's a perfect square is when we do completing the square. We haven't used that method. What other method do you want to use? Factor by grouping. All right, Power Rangers. All right. Here goes. This is 4. This is 5. And I want you to finish that one by yourself. Let's see how you do. Yeah, just give it back to Freddie. All right, factors of 4 that add up to 5. 1 and 4. All right, finish it off without looking at your notes. All right. 0 equals x squared plus 1x plus 4x plus 4. Group. First 2, second 2. GCF here is x plus 1. GCF here is 4. We got x plus 1 equal to 0. So what are my factors? X plus 1. What's left? X plus 4. What's the last step? Put them equal to 0. X plus 1 equal to 0. X plus 4 equal to 0. Have you guys seen that movie, Groundhog Day? This guy that goes to this town in winter, and then every day that he wakes up, it's the same day. Yeah. We just did that, didn't we? Isn't it the same thing? So what makes it different? At the beginning, we started the other one with what? Substitution. And what is this one? Oh, my bad. The other one was substitution, and this one was elimination. We eliminated, but we end up with the same thing. What do we do next from there? We need y values, don't we? So we take this equation, y equals x plus 1. We write it twice. Y equals x plus 1. But instead of x, I'm going to write -1 and -4. Y equals -1 plus 1. What is -1 plus 1? 0. So what does that mean? When x is -1, y is 0. This one, y equals -4 plus 1. Y equals -3. What does that mean? When x is -4, y is -3. These are my solutions. And what does that mean? Tell your neighbor again, please. What does that mean? Where both graphs intersect. Are we done? No, what's the third method? By graphing, all right? So let's do it by graphing. Get your graph paper in front of you. I ran out of those, so you get one out, an extra one from yourself. Let's start with the easy one, which is the bottom one. In order to graph that second one, what do we need to do, Jacob? What's that? The second one? Slope-intercept form. So that means I need to leave y by itself. Add x, y equals x plus 1. Is it in slope-intercept form? Yes. So where do we start? +1 of y, which is right there. What is my slope? 1 over 1. That means one step up, one to the right, plot your point, do it again. One step up, one to the right, plot your point, do it again. One step up, one to the right, plot your point, do it again. And once you graph your line, make sure you extend it so that it crosses the entire coordinate plane. All right, we're done with that one. Now we need the first equation. Has to be solved for y, is that correct? So what do I do here? Add 6x, add 6x. So I end up with y equals x squared plus 6x plus 5. All right. So when we got to quadratics and we were looking at certain patterns for it, what did we learn? That the 5 is our constant. What does that mean? It's our y-intercept. Where's 5y? Right there. So our parabola is going to cross through there. What do we know about this positive middle term? All right, so what does this one tell us? If it's positive, that it's going to shift the whole parabola to the left. If it was a negative, it would shift it to the right. But right now we can picture it. Look up, guys. Can you picture it coming through here, right here? Yeah, because it's shifted to the left, right? If it's crossing through here at the y, that means it's going somewhere here. So I'm going to use values from -6 all the way to -1. So let's make a table. X, y, -6, -5, -4, -3, -2, -1. No. What? Sorry. Hold on, let me move this. I want to place it right there. All right, so I can show you the work. Here it goes. I'm going to start with -6. According to this, it should say what? -6 squared, is that correct? What is -6 squared? 36. What is 6 times -6? -36, then you bring down the 5. So what happens here? They cancel and we're left with 5. Next one, -5 squared. What is -5 squared? 25. What is -5 times 6? -30. Bring down the +5, combine like terms, so this is 0. Next, what is -4 squared? 16. What is -4 times 6? -24, bring down the 5. 16 plus 5 is 21, minus 24, that's -3. Okay, so by looking at the parabola, we said this is the y-intercept. This one tells us that it's going to shift this way. So if this is the y-intercept, so it could go down maybe right here. But I said I'm going to start from a little bit over so I can. We did an activity when we did quadratic equations on where it shifts, remember? Left, right, up, and down. Yeah, so this one went up. All right. Next. -3. What is -3 squared? 9. -3 times 6, -18, plus 5. 9 plus 5, 14, minus 18, that's -4. Next value, -2. What is -2 squared? 4. -2 times 6, -12, plus 5. 9 minus 12, -3. And the last value, -1. What is -1 squared? 1. 1 times -6, -6. My bad. -1 times 6, -6x. Bring down the 5. Sorry. -6. Plus 5. What is 1 plus 5? 6 minus 6? 0. All right, let's plot those. -6, 5. -6, 5 is up here. -5, 0. -4, -3. -3, -4. -2, -3. -1, 0. All right, let's plot our graph of parabola. What do you guys notice? It intersects here and here. So what is the coordinate here? -4, -3. And here, -1, 0. And what are these? My solutions. Did we get the same thing as the other ones? Yeah, right there and right there. So that means it is true. Now, your home plate is not going to ask you to do all three. They're only going to ask you to do it either by graphing, elimination, or substitution. So you pick a method. Okay? Have a good one, guys. Once again, home plate is on page 198 only. Have a good one, guys. Enjoy your home plate. Make it a math family night. Bam. Let's go. See you guys tomorrow. Bye. 10.